Hello Year 7 and welcome to our 5th video here for measurement, and today we're looking at the area of parallelograms. We have looked at the area so far for rectangles and triangles, but today parallelograms. What's a parallelogram? There are a few different definitions. The one I'm going to run with today is a shape, right, that has two pairs of parallel sides, four sides altogether, and two pairs of parallel sides. Right, here we go. Here is a parallelogram. These little arrows drawn on the sides, right, indicate that the sides are parallel. It's a bit like those tick marks that we had on a square showing that the sides were equal in length. These arrows indicate that the sides are parallel. So one arrow each on these two somewhat vertical sides, right, indicate they're parallel, and the horizontal ones have double arrows on them, right, to indicate that they're parallel with each other. Right, a parallelogram. I want to find the area of a parallelogram. And I want to think about it this way. If I take that shape and I chop it up and move the pieces around, the combined area of all those pieces isn't going to change. No matter how many times I chop it up and move the parts, I still have the same area. That's an important concept for our next video as well. So I'm going to chop my parallelogram up a bit and move the bits around. So watch this. I've drawn a vertical line here. I've sort of separated off a little triangle. I'm going to move that over there. And because they're parallel sides, they're going to match up really neatly. And what I'm left with is a rectangle. And rectangles, really easy to find the area of. Okay, the area of a rectangle is length times breadth. Now, because this didn't start off as a rectangle, it started off as a parallelogram. Just to be difficult, I'm going to change the names I give to each of my dimensions again. A little like my triangle, I'm going to call, right, that dimension there the base. I'm going to call that the base, and this the perpendicular height. So BH like a triangle, not LB like a rectangle. Base and perpendicular height are the two necessary dimensions. Now, if I look at those two dimensions, the base and the perpendicular height, and I consider that as a rectangle, I can easily find the area as length times breadth, or in this case, base times perpendicular height. And we said chopping up my shape and moving the parts around doesn't change the total area. So that means also that the area of my parallelogram, remember this, is the base times the perpendicular height. It is very much like our triangle formula, which is half the base times the height. But this time it is all of the base times the height. Okay, it is the product of the base and the perpendicular height. Rightio. There's another formula. We have three formulas now. LB for a rectangle, half BH for a triangle, and BH for a parallelogram. Here's an example. Calculate the area of this parallelogram. We have a parallelogram. We've been given the necessary dimensions. We've got the base and the perpendicular height, which is all we need. So the same steps as before. We have a neat labelled sketch. We have the formula. We have the substitutions. We substitute into the formula. Then we evaluate that expression and make sure that we use the correct units. Now, in the last video, I made a mistake. I used the wrong units. But this time, being consistent throughout, we used millimeters for our dimensions. And so I have an area in square millimeters. Remember, not millimeters squared, square millimeters. So 230 square millimeters. There we go. Very much like the procedure for the area of a rectangle or a triangle, just using a different formula to begin with. Okay, that's the area of a parallelogram. Let's go over these things one more time. The area of a parallelogram is the product of the base and the perpendicular height, giving us a formula A equals BH. To calculate the area, we're going to set out our work using these 5 steps. Draw a neat, labelled sketch. Write the formula. List the substitutions. Combine the formula with the substitutions. That is, substitute into the formula. Write an expression for the area. And finally, evaluate that expression using the correct units. Okay, that's it. We have looked at rectangles, triangles, parallelograms. They're going to cover us through quite a long way. Our next video, and I think perhaps our last for measurement, not sure, but it might be our last, is going to be on composite areas where we combine some rectangles, triangles, and even perhaps some parallelograms together. That's it for today. If you have any questions, make sure you shoot me a message or ask me in class. I'll see you in our next video. Thanks for your 7. Bye.